All right, we are back and we're going to spin up Firefly and we are live. Fantastic. Okay, so um, let's get to this. So yeah, we had talked about, okay, check content length. Um, so this was, we were experimenting with, what does the ideal flow with the system local resource management look like, or the locality based resource management, and our abilities there, with regards to, basing something off of this, an open architecture spec where we'd have, essentially dynamic levels of reconfigurability. And if you're thinking about this, really, all we're saying here is it's just a name for not having to bang your head against the wall when you need to recompile several pieces of, say, a Linux distro in order to deploy your application, right? So uh, if you've ever had to do that, you'll know how much of a pain that is, right? And so you got to go get all these user space components. You got to set up your build environments for each one. You got to go do your compile. Okay, basically what we're saying is overlay, boom, right? What are my patches I want to throw on top of this thing, right? Now make those patches work with whatever the distro build environment is, right? So maybe I need to run changes to Firefly CLI on top of like Alpine or on top of Arch, right? So we're going to have underlying orchestrators that facilitate the rebuild via the package management system that is for that distro, right? And that way you get cross distro application of these overlays. All right, so yeah, check content length, trigger operation to request disk quota, um, resume download, or receive body, content body, uh, once, ticket for once, quota confirmed available, uh, once content length confirmed available within quota, system local resource management, which is, uh, aka I.E, traverse input parent and interact with backing uh, scarce resource. Okay. Yeah. So right now we don't have that. So we're just going to do it like here. And we're going to store the cache. Oh, and the other thing that we'd looked at was basically, okay, so say that we want to snapshot the state, right? And if we appropriately, so right now what we have is this little Firefly config, right? Essentially defines its own interface, right? Well, it's its own plugin, right? Um, so, and yeah, there's a lot of awkwardness happening here. Maybe we'll just spin up Firefly. Yeah, we're just going to spin up Firefly. There's a lot of awkwardness happening here trying to implement this as an operation, because the awkwardness that we're seeing here is the stuff that we're going to fix by doing the turtles all the way down sort of thing. This is just like an example. This is now an example of why the API is awkward and the things that need to be done to fix it. So we're just going to go and nuke the rest of this. Or no, let's not do that. We should make sure that this is reproducible. Okay, so, okay. So we're going to say, maybe this is, yeah, Firefly import. So this thing is going to takes, where's that genfunc stuff? That was, that's in Dataflow as class. So, oh, so that Dataflow as class, that will also help us with this type of thing. So when you define a data flow, so because there's, and I think we've gotten into this, because of the context, the double context entry, and the way that the operations are really just like a single function call, the stub, the function prototype, the operation, right, is can be different than the operation implementation, and therefore you can have the operation implementation introspect the operation and understand, if its behavior should be different for that, for that particular operation that it is in, because you're mapping operations to implementations to instances, right? And you can reuse instances, you can reuse implementations for different instances if you wanted to, right? Or you could scope them and you could basically reinstantiate. And so this is an example of where we have separate instances, and but we're using, well, let me just show you. So run data flow. So run data flow, default inputs, flow inputs. Okay, so basically inputs to add to the data, the key value mapping of context, string value pairs. Let's check out our examples. Okay, so basically, yeah, so if we pass, basically what we're doing is we're passing this here, right? Same thing, only value definition. So it's not input object. They're raw. They're unconverted types. That's even worse. Something's not ideal with the comment text, and it's barely visible in that dark blue. Um, so yeah. What is this? Last path. Last element in path. The following shows how to use run data flow with custom inputs and outputs. This allows you to run a subflow as if it were an operation. Okay, and this is what we're interested in. So basically, we can say, okay, so this last path is an operation, which is a subflow. We're going to instantiate run data flow within our data flow, and we're going to say, the instance, right? So this is the instance, right, as exists in operations, which is our prototypes, is we're going to modify the instance and change the inputs and the outputs. And then we're going to, change the config, or yeah, we're going to instantiate using that config, right? So that it uses the subflow. And then basically what'll happen is that when we come in here, and we'll end up triggering this run custom, right? And run custom is going to go look at the inputs, right? Self parent op inputs items, move string, context input name, context input definition. So this is some really rudimentary stuff right now, where basically we're saying the first input given in a custom is the context, which is why we did this definition URL. Okay, so we're basically, this is sort of like our record def. So this all needs to, and this is why all of this, we have so many implementations of the same thing, right? We just didn't know that. Sometimes we didn't know that and we didn't know how to unify. Now we know how to unify, right? So this is what we're doing. We're going through and we're unifying. Um, okay. So essentially, yeah, so this is the point. Basically, the point is that you can have a custom run function if there are custom inputs. So we're actually going to just copy this directly. So right, okay, so this is from DFFML, and we'll make a note. So okay, so data flow from peer ID. Okay, yeah, we were talking about that. And then we have, Firefly. Okay, we were making this operation to or we were making this context manager which downloads Firefly. And okay, we don't need a context manager for that because uh, cache download unpack archive is going to be, oh, we do need a context manager. Okay, so to do remove context manager when, okay, you know what? Okay, so to do remove context manager when we fix op imp enter and ctx enter to not attempt context entry before setting return value on parent uh, key given remove context manager when we fix op enter and ctx enter to not attempt context retrieval before setting return value on parent key given if return value is not a context manager. Is there an async null context? I'm not sure if there is. That could be helpful there. So basically that way, instead of, so right now what happens is that whatever you return from this function, since it's a lambda, right, you have to return something that then can be called, and then the return value is a context manager, which we enter. So if you just pass a regular function, it's just going to blow up. So we want to uh, call instead of entering their context. So basically, if we see a coroutine, we're just going to go call it instead of enter the context. And so we'll let this run, or sorry. Um, we will, um, we're going to take this run data flow context. We're just going to find replace Firefly supernode. Or maybe we'll say Firefly import. Or maybe we'll call this inputs to ODAP. Or maybe we'll just call it ODAP. All right. So we didn't get Okay, so let's go read a little bit more about this. Remember, always read the security considerations first. TBD, not good. Red flag. Red flag. Major red flag. This thing expires in a few days and they haven't written anything about security. Major red flag. Man, that's unfortunate. So what are we going to do to get this reviewed? I guess we could sit here and review it. Don't really have time for that though. We could cross our fingers and hope that somebody secures it by the time we go full blown with this thing. I think we can basically assume that. Asset locking or escrow. Okay, I'm glad that there's locking. Virtual asset transfer between. Okay, so basically this is defining between blockchains, and then we can extend that concept to between decentralized trust. Oh, hey, decentralized trusted computing base. Hey, that's interesting. Oh, Ned! Ned! Ned, what are you doing? I just talked to you. Well, this is perfect. I talked to Ned several years ago, and that's how I learned that this is the way things are going. And look, here he is. Hardware roots of trust. This is all of the stuff that we're going to be leveraging. This is exactly. So we need to go talk to Ned. Okay. Ned. This is perfect. This is a roadmap, is what this is for the different underlying secure further considerations. When did you publish this? December 2019. Wait, I think I read this. Yeah, I think I read this a while ago. Okay, so we need to go ask Ned what is the most recent thing that he's written. It guy's prolific. I should have thought of that. I thought I talked to him. I need to go talk to him again. All right, so this is 3 years old. Yeah, I just talked to him about decentralized identity. What did he say? Maybe I forgot. I've dropped a lot of packets lately. Yeah, he said that, he would like to see the UCAN stuff support CBOR, and I talked to Brooklyn about that. Oh, we should go check in on that stuff. So, let's see. So this looks like something that we're going to really tie into our um, identity aware context stuff in terms of like transferring around user permissions as we run these things. So where is, hey, look at this, Web3 storage. What is this? 9 days ago. Okay, so this is another, okay, so if you're building an NFT market. Okay, so basically, so just like these NFTs, right? So the NFTs, all of the data, basically anytime you create an operation, there's going to be an NFT for the output is effectively what we're doing here. Um, and then that data, the data for the NFT lives, off chain, um, and it lives off chain as accessible by the data flows or the open architecture, which gets embedded right as the DNA. The encoded DNA is context aware embedded. Oops, I'm knocking over the server over here. Okay. Are we on the internet? We are on the internet. Okay, great. This is 3 years ago. I think I remember reading this. Um, Last talked to him about DIDs. He said CBOR would be great. And so I'm guessing that's because DICE stuff. There's this DICE stuff. Microsoft, I think, is device identifier composition image, and said this is robust, resilient, recoverable IoT. So this is basically we're going to tie this DICE stuff in with, we're going to tie the DICE stuff to the DIDs. That's our goals, part of our goals right here. We want to tie DICE to DIDs to CICD to ML, right? Um, okay, computed device identity. This is what, okay. And if we can do that, then we can end up with robust, resilient, recoverable Alice. Okay, so let's see. So participants when the UCAN author are identified by a key pair with the private signing key corresponding. Okay, so saving unloaded key pairs. When saving to disk, take care to save. Creating a UTAN token, creating a root token, derive token, creating a child token. Free storage for NFTs. Okay. Okay. So this NFT.storage. Okay, because if we can basically say the data flow is the NFT and the NFT is in a um, upload often Filecoin decentralized storage network. So are these people using DIDs? Okay, so it looks like there's some pretty good cross compatibility here. So decentralized. We want to know about decentralized identity, the road to decentralized identity, Filecoin spec. I'm not seeing this look like it has NFT storage. Okay. So what is this UCAN storage and I don't understand. Using UCANs with NFT storage. Use of UCANs to delegate upload permissions in NFT storage is currently use of UCANs to delegate upload permissions in NFT storage. Have any feedback? Could have discussion. Let's go check out this discussion. So this is telling us that we can use these UCANs to authenticate to the NFT storage API. Okay. Is this thing blog post? See, this is what we want. Yeah, so maybe we need NFTs. We want NFTs on DIDs, on pure DIDs. If we can do NFTs on DIDs, then we can do pure DIDs. And then we can build our graph. I'm wondering if there's something that's like, okay, so this is great. So we want to intercept with this stuff. We want to intercept with the UCAN stuff. So we know we want, it could be good. So Seaboard intercept, our intercept route is identity aware context, to UCAN to CBOR, which is, via CBOR, DICE. So this is going to work device attestation. So this is how we're going to end up with our hardware root of trust. So we're going to tie our identities and our credentials, and we're going to hopefully end up with this authentication mechanism via UCAN, via CBOR, which is interoperable with the authentication and attestation mechanisms that our devices are using. So we're going to prove that we are have certain claims just in the same way that devices prove that they have certain claims. And then this is going to allow us to have this interoperability between execution as a service where you have some like human in the loop stuff, right? And so you have attested credentials for which humans are doing which things, and this is what allows you to swap out, basically subcontract any piece of your open architecture or have a device do it. All right. Allows us to share attestation via open creds type stuff across humans/machines when we need to mitigate when our strategic plans are attempting to mitigate for when our strategic plans are attempting, allows us to share attestations via open creds type of stuff across human/machines when our strategic plans are to mitigate risk via execution of operations via implementations which have attested properties. So it's just going to simplify our overlays because they can just look at UCAN stuff instead. So let's go check that thread. We will spin up Firefly. Maybe. Okay, so here's this NFT storage thing. So this thing, free decentralized storage and bandwidth for NFTs and Filecoin. So examples, UCAN node. Okay, basic upload using UCAN token. Okay, so this is great. So here's something, this is part of our on-ramp, off-ramp setup, right? When we deploy these to a live environment, maybe this can be part of our bridge stuff. So, I mean, unless we can just, so what do we want to do? I mean, okay, so we want to understand, so why am I off looking at this stuff right now? So why am I off looking at this stuff? So if we want to be able to mesh, we want to mesh the goal, immediate goals, leverage existing off-chain storage interfaces provided by NFT storage and authentication via UCAN based on DIDs to support or to act as gateway, as portion of gateway for our reverse engineering environment where we attempt to get data into Firefly network, Firefly DLT, based on DIDs. Okay, so we could go spin up the Firefly thing right now, right? And we could go dump all of the we need to talk to Brooklyn too, and find that discussions thread. So where's that you can, because I promised that I would provide feedback when I have time, and now we have time, and hopefully um, we have a little more, we can have some feedback, right? So let's go give some feedback. Um, discussions, transparent format agnostic UCANs. Okay, yeah, so this is the thread. Let me link to the recording here. We're at 35 minutes in, just because this could be helpful if we go talk back. Recording where we are talking about this is about 30, what was it? Probably 30 minutes in, 30 minutes in, into blank. The fully connected development model. We're going to capture all of this information. So let's go spin it up. All right. So what are we looking at here? So we are looking at, okay, so thanks for the comments. Okay, so more discussion February 3rd. The P2P. Okay, was there anything more down? When was this? When did I last comment on this? So this was back in March. Okay, so we need to, okay, increasingly aware of custom comments. Okay, so looking at this again, really excited about it. Would like to see CBOR support still, as that will simplify. Okay, so but that's not the question. We're not answering the question. So what is, let's just put a note. I think I'm too in the zone on this right now. So arbitrary resources, degrees of freedom, UCAN version. Yeah, there's, we looked at that the other day. Auto codec, essentially referencing Web Essential model. Auto codec, big hammer for. I believe what we're suggesting is this sort of auto codec, is this open architecture. Oh, yeah, auto codec. Yeah, we're basically, so the auto codec maps to auto codec maps to our shim discussion, manifest encoding as DNA discussion, right? So that's the DNA is the codec that we're encoding to, if that's the right the words. God. Oh no. So all right. So let's go look at this. Okay, so we would like to have the NFT storage thing. So if we can spin up the NFT storage to point at a DID-based blockchain, we can go prototype all this very quickly and then dump the chain and then reconstruct the format on the other side. So let's go look at this NFT storage stuff again. So this is, excuse me. So we've created bulk imports. Okay, that could be interesting. We want to do some bulk imports. Import list of CIDs. So IPFS. Okay, so we're going to store it in IPFS, but where is the chain? So what chain? Nft Storage. About. Okay, yeah, off-chain data. Data is content address using IPFS, meaning the URI pointed at a piece of data is completely unique to that data. Okay, so we're gonna run this thing. So we're gonna run this thing. We're going to, so what if we want to host it ourselves? Okay, we have a slight problem. If we clone a Git repo, the computer will blue screen. Um, why? No idea. Okay, NFT storage, but I'll give you content ID of your upload when minting an NFT to make it truly immutable and performantly available. Okay, performantly is quite the claim there. I'm really curious about that. We'll see. So uploading to NFT. So your smart contract base URL. Smart contract base URL. Is this something? Feels good to discover a new sound. A lot of time APIs come into use for people. Give them a comment. Name. Okay, so token URI, base token URI, token URI. Okay, so big data interchange. Okay, so base URL APIs start linking to a directory. Okay, so um, this didn't explain anything to me. I mean, I didn't really read it, but store and mint NFTs using custom metadata. Sounds up our alley. Okay, single file. Okay. So we can upload multiple files. FS content. Hey, look, 100 megabyte single file request limit. Preparing your metadata. Once you have all your assets stored, you can upload your metadata, including minting your NFT. So you can mint tokens using the blockchain platform of your choice. Avoid storing HTTP URLs on chain. That's convenient. Your way to retrieve NFT data from IPFS may involve using an NFTs HTTP gateway. You should avoid storing HTTP gateway links in smart contract or other blockchain record. Instead, store IPFS URI, which doesn't need a single gateway, provided you rewrite this URI to a gateway link at the last mile when displaying when displaying the NFT on the web. So okay, so what is this saying? So this is basically saying, your IPFS is like this distributed data store, right? And so your HTTP interface is really this Web 2 thing. And so if you find yourself displaying, if your context is such that your parent context in some parent is such that you are going to render this thing to a user via HTTP, you need to make sure you change the reference link to go through the HTTP gateway for IPFS. And so this is the type of thing that we're going to have the visibility into. We would store things, yeah, in IPFS, or we would probably actually store things in an operation, which will then yield us something. But we need to see, so store a directory of files. NTFT projects. Okay, creating a project. Install NFT storage files from path. Adding the upload code. Store directory. So basically we can say, okay, NFT storage token. Okay, so we can store a whole directory in NFT storage using UTAN tokens for dedicated authorization, using UCAN. Okay, so NFT storage API. So I'm confused. Is this NFT storage I still don't quite understand whether this is open source or not, because we need this to be open source. Can we run this? Development. Getting started. Development. Okay. The API server. Okay. So our plan. Let's update the plan. For this recording. Deploy NFT storage with storage and interact with it via UCAN token auth. Then ensure URSO. Ensure NFT.storage can interact with DID-based blockchain. Firefly. Okay, we're going to use Firefly to do that. Firefly transact question mark, because we're not sure. Dump resulting blockchain. Dump resulting chain, reconstruct chain via Python code in Dataflow operations. Pure DAD. So the tree has it wrong. Folder named peer ID instead of what it should be. Peer DID. All right, so maybe we'll fix that too. Okay. Okay. So let's see. So where's this? Okay. So what endpoint for production Postgres, cluster node, so IPFS, staging database, Postgres. Oh, it turns Postgres into REST. I was like, Okay, precision. Okay, yeah, token for, what is this? Is this some kind of telemetry? Pinata. What is this? Share your NFT one. How? Okay, this is some kind of NFT thing. DAG cargo API. What is DAG cargo? NFT storage DAG cargo. Work in progress. Okay, so this looks like it's under development. This name will not survive. Do not pull gold lead maintainer. What is this person working on? Oh, this person is familiar. Why are you familiar? Possibly forming a directed acyclic graph from stream parts, stream dagger. Wolf's criteria, so this sounds somewhat similar. Okay, it looks like maybe abandoned. Okay, UCAN private key. Okay, great. Front end also needs environment rest, such as Cloudflare pages, secrets. Okay, so they're gonna production environment rest local. Okay, so magic secret key, magic link app. What is magic link? A personal account on magic link. Delightful auth for Web3 onboarding. Are you fucking kidding me? Okay. Eventually it'll be UCANs. So what, I don't understand how they point at a blockchain. Where are they putting it on chain? I see them putting it in IPFS. So maybe I don't understand something. Probably. Using NFT storage. Before you can create the blockchain record, you'll need to store all the data off-chain. Comprise the NFT packet. Once everything is stored, you can use the IPSS fill metadata link from the on-chain token to everything else. Below are examples of storing NFT assets and metadata using JavaScript and HTTP API. Both use the store. So we can use the store. So there's this ER3 standard metadata. So we need to make sure that we conform to this. Is probably what we're going to see. Okay. Yeah. Using custom metadata. Okay, so what are the metadata schema? URI, token CDN, token. Okay, the URI value for the ID substitution by clients, the string ID existent in a URI, clients must replace actual decimal form. Okay, so basically, so metadata URI. Okay, so this is saying basically um, standard interface definition, standard interface detection. This sounds like something we care about. We care about standard interfaces. Standard interfaces like this ERC20 token interface. Um, Okay, publish and detect standard interface detection. Okay, supports interface ID, interface ID, interface identifier. Okay, okay, so basically they just assigned this supports interface is this. Okay, so the source contract makes a static call to destination address with input data and guess. This corresponds to, okay, so this corresponds to this contract support. So basically we say call this function. If it doesn't, then it doesn't support. So basically, does contract implementation. So there, okay, so, all right. Okay, so you see one. Oh, sorry, Ruffles. Um, okay, so this is the interface selector. So maybe we need to encode the data flows to the smart contracts. If we encode the data flow to the contract. I don't want to set this to gas. Gotcha. Okay, so basically, so this is cool. So basically, I think we can use this type, so we can encode to this type of thing. Uh, on try, so detection of methods for smart contracts. Should we encode to smart contracts? Okay, so we're trying to figure out where does the data flow execution engine fit into this this on-chain, off-chain, blockchain model? Uh, okay, so this builds on that multi-token standard. Standard interface for contracts to manage multiple token types are deployed. A single deployed contract may include any combination of fungible tokens or non-fungible tokens or any other configuration. Okay, so these are the different data types that we might be working with, right? So the contract is the data flow, I think, and then the data flow types are the inputs, right? The NFTs are the inputs, or the FTs are the inputs. Safe transform file. What's safety call? Safe transfer from. Safe batch transfer from bounds from bounds. Okay, so right, so we just want to ride on top of this stuff. We want to put, I think this is just going to be the tokens and the blockchain and all this stuff. I think this is going to end up being, I think it'll be good to be based off of, because then you can leverage that for the reward system for execution. So basically you can issue, I think you could issue a contract that says, please execute this thing, or please, like, you could issue a contract that says, um, pay this address. Yeah, so if you pay this address, then it does this thing, right? And that ends up creating an input object, which is itself, so basically if you execute the contract will, so basically you want to have some other nodes in the network run a data flow, right? So I think you issue the contract, or yeah, somehow you expose this interface, you offer like the bids, right? So people can bid on it, and then people can execute it. And so if they go execute it, then they, um, so basically when they execute the contract, they have to be able to prove, so when they execute the contract, they have to be able to prove that, what is it? So they execute the contract, and the contract is to do stuff off chain. And so to do that, you need to have some kind of check on the risk tolerance ahead of time. So to execute contracts, which will go and fetch off-chain data. Okay, so executing contracts, uh, uh, execution of contracts where um, uh, rewarded party executes off-chain data flows, off-chain system context. Execution of contracts where rewarded party executes off-chain system context needs Oracle needs information within network to make decisions to upfront to make decisions about if a party is able to accept a reward, or so basically you put this thing out there, you say, hey, I will pay you this much money to do blank. So you put out blank. You put out system context, so process flow. Publish strategic plans, publish system context they want executed to chain. System context they want executed to chain. So flow rewards. So this is we're exploring a possible flow here where, agents are communicating together, but they need to be compensated somehow, maybe for their compute time or something. So This is a tangential thing, so just exploring how this might work. So, okay. Okay, they want to execute it to the chain. Okay, so they basically, this is like a call for proposals to execute, right? Um, so others publish their proposed system context, which so others publish proposed system context. Um, other agents in network publish proposed system context in proposed uh, applicable system context. Hey, I want you to do something. All right, this is how I could do it. Okay, so this includes provenance information that would be provided. So basically, then they say, hey, I can do this thing. Here's the provenance information that I could provide if I did it, right? References to previous executions um, with and then includes what provenance information would be provided. So basically, uh, so what salsa level can you meet, right? Um, So we put out this thing. We say, hey, I want you to go run some code, and all the agents out there looking at the chain, they say, well, okay, well, I'm doing similar work to that based on Alice's brain is thinking, and she's thinking, I'm doing similar work to that. On these trains of thoughts that I'm operating on, because of course Alice is across many devices, and she's sort of forming this. Yeah, she's yeah. Okay. So basically, everybody's got their own Alice for different purposes, right? So all these little versions of Alice are sitting out there, and they're listening to the chain, and they're trying to complete move their strategic principles in the right direction until they're, turned off, right? So, um, uh, when we do that, so we have this possible flow where and we have to think about when these contracts are issued, all the data needs to be on chain already, right? Because the decisions that are being made here, and we also want to think about the properties of trust that we have in the physical world and extend them to the digital world, and not really, come up with too many unreasonable expectations for the digital world, right? So. How are we going to do that, right? Well, so before any money changes hands or any reward system or any token or whatever that exists, I'll be honest, I don't really understand blockchain stuff. That's what we're doing here. We're going to figure it out. Once please correct me if I'm getting something wrong. But once so we can put these contracts out onto the network. We can basically issue a contract. We can issue an NFT. We'll mint an NFT. The NFT will so we'll mint an NFT on a DID backed network, right? And the contents of the NFT will be a encoded system context, right? And we are going to encode that system context in a in a context-aware way, right? This auto codex sort of thing that was referenced in that other thread, which is basically okay. So if I'm looking at something on a blockchain and I'm pretty sure it's a system context, I should make these assumptions about decoding and then start from there, and that's what the shim will do, right? Um, so basically, we're going to publish. So we're going to mint it. We're going to mint them an NFT. We mint an NFT, and the NFT is basically like a request for execution, right? Or so we can mint NFTs that are so basically so call for proposals to execute or hypothesize, right? So process is mint NFT for system context on DID backed chain. Um, right. Then other agents in network publish proposed applicable system context, which including what provenance information would be provided, so you can map that similarly to salsa levels, and if can that agent meet? So basically, I'm going to tell you, okay, I'm going to publish another thing to the network, right? And this is my bid on the NFT, and um, the bid is like a reverse bid. So it's like, okay, you pay me if I buy this NFT, then you pay me, then you accept this contract, right? So bid is like like a reverse bid, right? So if I buy the NFT you just minted, um, then then we have agreed to a contract which says if agent buys the NFT, the original system context, the system context originally minted within this example, right? And so we can sell, obviously, so we can sell, we can, I think, isn't there some concept, I really have no idea, but I think there's some concepts where, you can have very similar versions of some, or I mean, ideally what we could do is we could allow multiple people to buy the same thing. So maybe we put a note here, ideally, uh, multiple people, multiple agents, ideally, or NFT can be purchased uh, multiple times. So maybe it's not an NFT, maybe we want a fungible token. Right, so maybe the use case, um, yeah, maybe this use case is that we want a fungible token, right? I don't know what the fungible versus non-fungible means, but suffice it to say, we this is the input objects themselves should be static, right? What is a fungible token? Concept of fungible versus not, or rather old token-like objects were changed as far back as the Roman Empire. Okay, so utility tokens give holders access to products or services that are blockchain-based. Security tokens are traditional assets like stocks and shares represented by digital tokens on the blockchain. The most distinct type of tokens are fungible and non-fungible. So fungible tokens are divisible and non-unique. Okay. So like money, interesting. Non-fungible token are unique and non-divisible. They should be considered as a type of deed of title or ownership as a unique, non-replaceable item. So maybe we use NFTs. So uh, NFTs might be good for results, outputs, and FTs might be good for issuing uh, requests for dot slash do, which is basically do something with this system context. And so why might be so NFTs are likely also a help to us in solving our um, uh, locking issue, right? Because explicitly they have to be transferred to be used. So this kind of, uh, could help with our distributed locking uh, situation needs. So, inputs with lock equals true are likely NFTs. Okay. So mint NFT for system context. Okay. So, okay, so we know that we want to put the input objects that have locks as NFTs, and my guess is that a fungible token is a simple case of a non-fungible token. I'm trying to make sure we're working down the right path here. Right. Um, should we be using NFTs? The NFT thing is attractive because of this off-chain link here. We'll take a look at the data. All right. Let's just see if we can spin this thing up for God's sakes. Okay, we want data, content stored value, data. Okay, so non-fungible token store data. So we know we want data. Okay, so Solana, Metaplex, consider people. SPL token. Okay, so create your metadata, Metaplex token standard. Okay, address share, basic off-chain metadata file, Metaplex NFT. Yeah, so going back to that example, I think that so we issued this request. Hey, I've thought of this thing. I would like someone to think more about it. Could somebody go run their models on it? Or could somebody go execute this flow? So hypothesis or execution. What's your bid for that, right? So then another NFT is issued in response, right? Another NFT is issued in response where the data within the NFT is stuff that's stored off chain, right? And that's okay because we just want to go inspect it. right? We were going to do, basically, is this system context valid, right? When translated into our environment, we're going to go run our analysis and we're going to see, all right, so there maybe somebody's proposing an aligned system context where it's going to work to, it's different. They're doing different work, but they're moving the strategic principles in the same direction, right? So we wanted to go, clean up the code base, and this person is going around doing refactoring. Okay, so well, you know, their refactoring work is eventually going to clean up the code base. So then we would say, okay, maybe accept contract, right? So there's sort of this proposal counter proposal flow, and then acceptance, and then and when the counter proposal is issued, so the proposal maybe could just be this single thing where then all of a sudden it's just good. Um, but it could also be, this case where the counter proposal is issued, right? And yeah, no. So the counter proposal has to be issued because we then need to go um, analyze the off-chain data within the counter proposal to decide if the provenance information that's going to be provided to us is acceptable, and check the history of that that executor, right? So we're going to basically make decisions of who to reward, right? Who to actually uh, so we'll okay. If agent buys system kind of originally, so they have agreed to kind of, which says uh, they will perform the will hypothesize or execute the system context uh, outlined in there. So we're just I'm gonna scratch this out. See, okay. So we said ideally, they can be purchased multiple times. We don't know about that, but we do know we're mitigated anyways mitigated either way via call response protocol system or proposal system. Uh, so basically, essentially, where we come to an agreement on what system context will be hypothesized or executed, and then accept contract on that. Okay, so if agent buys the system contracts originally minted within this example, we have agreed to contract which says they will hypothesize or execute system contracts outlined in there as outlined via their response system context counter proposal. Um, okay. Um, so counter proposals evaluated uh, using evaluated using uh, uh, by mapping by mapping or by analysis of historical data, agent execution data, to calculate risk tolerance review system to calculate risk tolerance. Counter proposals evaluated by analysis of historical agent execution, data of historical proposed agent execution, agent with counter proposal data to calculate risk tolerance, based on review system of previous quality of execution or via attestation right? So we could, they could basically prove to us that they have the hardware somehow, right? That they could, they could issue a counter proposal with an attestation within the counter proposal, which is a valid attestation, which says, hey, I have, I have, the hardware that is attested to run this thing. And I, have not, basically, because you're outsourcing your work, the work that you want done, right? And so you have to vet it somehow, right? And so you can do, you can use whatever mechanisms you want to do that vetting, right? You can pull in, third-party data that from people that you trust to say, hey, who, have people that I trust. So if it's Google that comes back and bids on it, and you're saying, create me a VM, and Google comes back and bids on it, says, I'll create you a VM. Well, you can basically, you might have a strategic plan in there that says, you know, auto accept offers, that are within these areas from these, or auto let these offers through the gatekeeper, right? Because I trust Google to run a VM. You may or may not trust Google to run a VM, but you may, trust Google to at least, spin up the VM for you, if that's what, and obviously, you have different threat models for different things, and you're going to take that into account within the evaluation. And that's probably happening within the parent system context, or within the system context, or so the plan that issued, or no, the prioritizer would prioritize which system context gets executed and also those counter proposals. So those counter proposals, uh, so counter propos are fed directly into regular data flow execution loop and prioritized and ran through gateway, just like anything else. Can apply overlays to do context / threat model specific vetting, right? Becomes trivial. So, great. All right. It's gonna rain. All right, I think I'm gonna get outside. No, it's not gonna rain. It's not gonna rain. We're gonna start the blockchain. All right, okay. So we found out NFTs. We found out NFTs are a good way for us to go. We don't want to store those NFTs in a DID-based blockchain. We found out some ways that we might execute thoughts in a distributed setting, obviously, yeah. So, and it should be noted that basically, it may be needed for the or yeah, they issued the counter proposal, which is effectively just another NFT. So the counter proposal is effectively just another NFT minted and then peer DID linked to original proposal. And I think can we accept when we form linkage, right? Does the DID com message require signing? Like, when original context, when DID for original context signs linkage, peer link is prompted. So when DID for original context is prompted to sign peer link is where we do our vetting, right? So gatekeeper, right? And then we form link, form peer / link if we accept, right? So basically, then you do your, and so you can pay via. So then you pay. So basically, they say, here's this system context. I want to link it. We'll link the DIDs basically by saying we'll mint one FT, we'll mint an NFT, right? We watch for minted NFTs, and the NFTs are the system context. Um, we then other agents out of the network say, oh, okay, yeah, I'd like to do that work. Sounds good. And then they mint their NFT that's a response, and via the peer DID interface, you have to have one peer agree to be linked to the other peer, I believe is how it worked. And so when we do that agreement, that is our point where we can jump in and run our vetting flows, and which we can overlay on there, or keep whatever. Once payment is received, agent will start work and then ask mint NFT, and then do whatever with results was asked. Right, so maybe you're minting maybe mint another NFT with results, maybe never hits chain. Just run that data flow. Right, okay. Oops, sorry, Ruffles. The very end of his day, oh, poor guy. Okay. Okay, all right, okay, I need a break. We'll be back. Now I have to change this again. All right, so what was this? NFTs. So, thoughts as NFTs. instead of thoughts on NFTs. Yeah, thoughts on slash as NFTs, right? Because our system context will be NFTs, which are our thoughts. All right, see y'all soon.